Hello and welcome to Slack Chats, Season 2, Episode 23. I'm Stuart Winter, the platform architect and developer of Slackware on the ARM platform. And with us, we've got Brent Earle, who's been helping with the R&D and the testing of Slackware ARch64 on the Pinebook Pro, the Rock Pro 64, the Raspberry Pi 4, the Raspberry Pi 3, the Orange Pi... So which is the other one? The Orange Pi R1?
Plus the 64-bit.
It's like a record catalogue.
Time on my hands.
Well, it's a lot of work getting that stuff working. There's so much detail involved and testing involved, every little detail to make it just as good as it can be. Over Christmas, I've done quite a bit of work. Fortunately, I had a bit of downtime and was able to make some fundamental changes to the Slackware installer on ARM, which is to add labeling support rather than, and use that as the default, rather than have a direct reference to the block device. So, for example, if you install so on the previous versions of the installer for Slackware ARM and also for Slackware x86, when you install it, the FS tab, the configuration file that expresses what the mount points are within the operating system and how to access those mount points, that had direct references to the block device. So you'd see /dev/SDA 1, 2, and that kind of thing, those kinds of block device names in there. And that works fine. And in fact, that's how it's been since the ARM port was done. It's always been like that. But one of the things that I noticed with the Raspberry Pi, and that started off with one of the previous videos, with one of the previous podcasts that we did, where the micro SD card was appearing as position 0 on the bus and then position 1. So it was alternating. I don't know why, but it also made me realize that because on the Raspberry Pi 4 in particular, not so much on the others, not so much on the others, say on the Rock Pro 64 and the Pinebook Pro, they have their storage is statically configured, and also with the Pinebook Pro, particularly if you're using, say, SATA, that's always going to be SDA. It's not going to change because of the way it's enumerated when it's lit up. But certainly if you have your root file system on a hot plug bus such as USB, it's quite probable that somebody's going to move things around, and when they next boot the system, it won't boot because the storage devices would have been enumerated differently. So, if you're on SDA on one boot cycle and you add something else in, it could be that your root file system is the block device that contains your root file system is now enumerated as SDB, and so the system wouldn't boot. So I thought that was quite a significant risk. So I've decided to add in file system labeling support into the installer so that now it would automatically configure your swap partitions and label them, and then have the references in FS tab and the bootloader. Not in the bootloader for swap, but for swap it's just an FS tab. And then for the root file system, it automatically labels that as well and configures that with a label in the FS tab and then in the bootloader. So the X-Linux config will now have root equals label equals, and then SLK root, which is what it's going to be called. So that's what I've done, and I've tested that extensively with all the different file systems, which I must say took ages to get all the labeling working and tested. And then supporting multiple swap partitions as well. So that's been done, and that works. And the only thing is that if you at present, if you have, say, another partition on SDA, let's say, then the root file system will be named, but the other one won't be. It doesn't. I haven't made it support labeling of auxiliary partitions, if you like. So I haven't done that yet. I might do at some point. It's not. I don't think it's particularly difficult to do, but so that seems to work, and that sort of removes one risk that I thought was quite high, that I thought was worth addressing before release. So yeah, I've been working on that. That's all done, and today I just realised that I was starting to look now at finalising the documentation for the Raspberry Pi, and I disconnected my RTC, the real-time clock, and as I was looking, and then I realised as well that I hadn't. Basically, I don't know if you've ever seen this, Brent, in some of the Raspberry Pis, not the Raspberry Pi 4, but the other ones. For many years, ever since Phil started on the SAPI project, he said, the Raspberry Pi doesn't have a real-time clock. Of course, I was naturally shocked and horrified by such a thing. But so what happened back in those early days, in the installer, it detected the hardware model from the proc interface. And then if it was a Raspberry Pi, some solid run Hummingbird or something else, then it would offer you a dialog saying, do you want to disable FS checks, file system checks? Because for EXT-based file systems, when you mount them, if the clock is significantly out of date, which typically is 1970 or sometimes 2003, depending on which vendor it is. So if the clock on the system is so out of date, then those file systems can't be mounted. So the installer would detect the lack of well, it wouldn't actually. The installer detected the hardware model type and then just said, do you want to disable the FS checks? So instead of relying on hardware model string, I've simply changed it to detect whether there is an RTC at all, and then offer the dialog box, and also sort out and fix up a few bugs in that simple script as well. Right, so Muttley is one of the Raspberry Pi 4s that I've been developing and testing Slackware AH64 on. And so what I'm going to do is I've just rebuilt the installer image with the latest version, from the latest code base. So I want to test how the RTC script behaves. So what I'm going to do is, at the moment, so I'm going to deploy the latest version of the installer to my Raspberry Pi. Why is that? TTY1. Oh, right. Yeah, okay. TTY1 is the virtual console. So I'm also logged into the Raspberry Pi I've got a keyboard and monitor attached to it, and that's where that is. I've got my present working directory is in /boot, so I can't unmount it. So where is it? Oh, this one. Okay. There we go. Right, so I need to unmount it first. If you don't, so what I'm doing here is I'm unmounting the boot file system, the two boot file systems off of the micro SD card. Because if you don't, and you overwrite it with an installer image, what happens is when you boot and you go to resize the boot file system, it always comes up with some warning messages. So we do that first. I've actually just about finished writing a script to automatically do this for me because I've got a little bit tired of doing this now. There we go, sync. And it's basically just going to do this. Just do that, sync and reboot. But so I can run it on the Rock Pro 64 and on the Raspberry Pi and not have to do much else. So this is quite convenient actually, this way of installing. Although one of the things I want to do, one of the things that I want to do is to get U-boot to be able to TFTP boot the Slackware AH64 installer like you can on ARM 32-bit. But I've not been able to do that yet.
I've actually been messing with that already.
Have you got it working?
It works with, well, no, it doesn't work. You can type the commands in manually, but I haven't scripted yet.
Oh no, typing it manually, that's all I want. It's just because when I started originally with the port, one of the reasons why I went to using X Linux is simply because I couldn't get the ARM way of doing things to work. No matter what I did, I couldn't get it to boot the kernel. But then as soon as I put the same kernel, same init into using, I booted it using an X Linux config for U-boot, it just works. So I thought, okay, we'll just go the easy route and do that. Although it was a good thing in hindsight because it means that the entire installation process is frictionless. So all of that extra effort was worthwhile in the end for the end product. But yeah, I still want to get it working though, because the only thing is that doing this remotely, if it screws up and it can't boot for some reason, there's nothing I can really do about it. At least with U-boot, I can, and also one of the things is that if I boot the installer and find the installer is a little bit buggy or it's not, the build isn't how I wanted it to be, I can just reboot back into the OS on it. Whereas whereas this method, I have to blat out the entire boot file system, so my installation is basically gone at that point. So
yeah, I'm just doing it because because I'm running out of SD cards. So
Yeah, unfortunately, at the moment it's been okay actually because I've got because I've still got this Raspberry Pi 4 on my desk, and I've also got a Rock Pro 64 on the desk. And the other Rock Pro 64 builders don't, they don't get to test out this kind of experimental behavior anymore. So I've got my ring-fenced primary build machines that I, only get the good stuff that's been tested on the stunt cars. All right. Oh yeah, the other thing that I was doing for the Raspberry Pi 4 installation documentation, in terms of storage for the root file system, I was going to suggest that you use the same USB to SSD card adapter and that kind of route. But actually, what I'm going to do, well, I'm going to do that for the Raspberry Pi 4 as well. But then for the video installation, I'm going to install onto an NVMe because I've bought an NVMe adapter, a USB to NVMe adapter, and I've just tested it. In fact, you should see it on here if it all works, which you actually don't. Aha, that's interesting. Okay, that's one of the things I wanted to test out actually. Oh no, hold on. Oh yes, you do. It's just there. Okay, good. So I don't have to. Yeah, there you go. I don't have. That's because of the screen, because of the terminal size and the screen. It's gone messed up a bit on here, but yeah. So SDB, this. Oh no, there we go. SDA. So this is a good example, right? So SDB here is actually that I've highlighted. SDB is an SSD drive on a USB adapter. Previously, on the previous boot, before I just rebooted it, it was SDA. And now SDA is the NVMe adapter. So this 465 gigabyte NVMe is I think it's actually 520 gigs. I bought an NVMe for the Pinebook Pro originally, which is like 500. Yeah, I think it was 500 and something gig. So this is because the Pinebook Pro for me is broken now. I've removed it and I've put it in my enclosure. So now the NVMe is in the top top right USB port on the Raspberry Pi 4, and it's now enumerated as SDA. So this is a good example of how the storage can move around on the bus, simply depending on when it's detected and which port it's in. So yeah, so you can see here we've got the NVMe. So what I wanted to do just to test, what do we have here? Let's look at this again. It's Linux swap. Yeah, that's okay. So if I do setup, let's see what happens. Swap. The Slackware installer has found the two Linux swap partitions because both of these block storage devices, the SSD drive and the NVMe, were both in use to house an OS. So they've both still got swap partitions. So let's take them both. I wouldn't normally do that, but yeah, there you go. So you can see that the installer is now okay, you could. The installer has labeled it as SLK swap 0 and SLK swap 1. Even on the next reboot, if they switch around, they will still be found because the Linux kernel will locate them by the label. So if we do SDA for root, and let's format that as ext4, see what happens. And then if we pick, so this is going to be example, if we pick, say, this one here and mount it, let's format it, there's nothing important on there. Mount that as /home. There we go. And now I'm not going to do it anymore. Right, and then we offer to resize. So we've resized the /boot partition on the micro SD card. Okay. Now it's mounting the, okay, yeah, there we go. And so there you go. So you can see the labels there. And as I said earlier, anything that's not swap or the root file system still has the static reference to the block device. So for example, /home may not mount on if you start moving things around physically on the bus. As I said, I may add support in for that later in the installer, but you can always go and subsequently change this. You can label the file system afterwards, and you can change the label in FS tab. If anybody really thinks that's good, I might add that in at some time in the future, but it will require quite a bit more work to get that done. But that works.
A lot of options too. code through.
Oh, that broke. Damn. Okay. So, okay. So that actually broke. Oops, set up. So I've done something wrong there. Which one is it? No FS check. Okay. I will look at that. Set partitions. So that should. Oops. I should have not catted that. Yeah, that should work. Why does that not work? Oh, because it's got the, okay. I'll look at that later. Okay, yeah, so the RTC stuff, it should work, but I don't know why it's not run from the script, unless it's broken. This file here that it's complaining about is the FS tab. Yeah. Yes, that config. Oh well, this config's got deleted that I've done. So this would be at a point in the installer where, because it's broken, you'd have to reboot to recover it. It's not. It's kind of it's in a bit of a bad state now. But yeah, so there's a bug there when I load that script, so I'll have to sort that out later. Okay, well, I tested that. I need to go and fix it, but at least the that should work. In fact, what we can do though is we can reboot it directly back into the installer. Let's see what happened there. Oh, by the way, one of the you know, you'd seen the errors. So you know, you showed me the error from the when you load one of the Pinebook Pros. When you load one of the modules required for the Pinebook Pro's display, I think it's the one called CDN.
Yes.
And it would. Ooh, look at that. Yeah, when that. Oh, basically, I fixed that firmware load error. I just woke up. Oh, there we go. So this is what happens if the installer fails while it's there. So yeah, you can see the OS has been the OS section has been inserted in your menu. So that gets done early on in the installation process, and then at the end of the installation process, it's removed, and you're only left with the boot OS, or at least you're asked about it if you want to sort that out. Yeah, so I fixed that firmware load error. It just occurred to me one day. I was in the kitchen, like, oh, I know what the problem is with that. It must be that basically it's because the module is being loaded from the OS init.rd, and the firmware blob wasn't in /lib/firmware/rockchip in the OS init.rd. Simple as that. So I've made a modification to the kernel slack build package building script to have the same plugin module to have the same plugin helper system as the others, and then so it has one for the RK3399 now, which it simply extracts the firmware blob from the kernel firmware package and puts it in the OS init.rd when the kernel's built. So that solves that. So the next time you get the updates, you'll find that that works.
Okay.
Oh yeah, did you say on the Pinebook Pro that the LCD panel works now?
Yeah, it does. As soon as I removed that one patch, just worked. So I was trying to re-enable the CDN stuff.
Okay, right. What I'm going to do. Okay, so what I'm going to do is I want to capture what that message was. I think it's 7, isn't it? Log closed screen.
It's really easy just to remove the Rockchip DRM module, and that error will pop up again with the CDN DP. So.
Oh well, it's fine. It won't pop up now anyway because the firmware blob's included with the OS init.rd. It's pretty small, so I thought I'll just add it in. I think it's possibly needed at that point. I thought the other option would be just to not load that module, and then that can be loaded later when the OS boots. But I thought if it does become, or it is required for any display, then it needs to be in there because I want the display operating as soon as possible.
Yeah, otherwise it's just a black screen for quite a while.
Exactly. Yeah, I don't think that's the best experience. I'm just going to run through this again so I can capture what the error message was when it came to load the SD. When it came to load the RTC script. Let's see. Yeah, it's resized. Oh, yeah, it won't matter about resizing it because it's already the maximum size. Right. Okay, so now it's doing the bootware hardware model platform again. Okay, so this is where it pops up with an error, isn't it? Let's see what it does. What? Okay. Right. Okay. Oh, right. I know what the problem is. Ah, okay. God, that's really annoying. I know exactly what that problem is. Actually, yeah. Okay. Yeah, it's because of this. There's some. What's we done here? Oh, there we go. Yeah, that's it. I think it was as simple as that, actually.
One too many card returns.
There we go. Yeah, exactly. Simple as that. All right, cool. Yeah, so this is the RTC checking script. I'll tell you what I'm going to do though, because I just want to test it without having to rebuild the installer. If I oh no, wrong machine. Almost rebooted the console machine. Hang on a minute. 7. Okay, let's reboot it. What I can do is I can just NFS mount the server and then copy that script into place before I go about the installation, and then it should work.
Yep.
But yeah, so on the AArch64 front, I think pretty much, I keep saying this though, I'm aware of this. I think pretty much everything is done. The only thing I've got left to do is the documentation. But I've been saying that for several months already. But it is true. Every time I say it, it's actually true. It's just that I end up finding new things. Oh, it looks like I've broken it now. Did that get broken?
So finding the RAM disk.
I'm not sure what happened there. Okay. Yeah, it is true. Every time I say it, and then I find things like the disk labeling that I think, no, that really needs to be sorted out, because I can just imagine, you know, I can just imagine people installing it and then finding it won't boot anymore, you know. So
Yeah.
it also means you can install onto the micro SD card if you really want to, as well. So that's going to solve that issue. But again, I will mention in the documentation about that I'm going to suggest people that they use labeling, and I'll include the commands required to label all of the file systems as well. But yeah, I think I've got, apart from this test I want to do now with the RTC, I think it pretty much is just documentation. Apart from testing things like sound on the Raspberry Pi 4, and you mentioned you still had to make some tweak or something on the Rock Pro 64 for sound, or was it the Pinebook Pro?
No, it just comes with the speakers muted in the sound settings. So I just have to unmute them. And the microphone is always muted too. Like that's probably good, but there's a lot of settings you have to adjust. And also mixer.
Okay, have you got a note of what the settings are? I can include those in the Pinebook Pro documentation.
Yeah, I can. It's just a matter of opening up the settings to the Rockchip sound card and then unmuting the right and left headphones.
Okay.
But it's funny. It also unmutes the speakers too. So
Okay.
it's the same setting for the two of them.
All right. Yeah, just let me know and I'll update the document with that. probably just a couple of lines, I guess, or a screenshot or something, I guess.
Yeah.
Look, here's an example. Look, so SDB2 is now the NVMe, whereas on the previous boot it was SDA, right? So my my SSD drive has returned to position A on the bus. So yeah, you really do need to use disk labeling here. That was a good investment of time there. We'll pick SDA. Actually, it doesn't really matter what I pick because this machine's going to get blown away anyway after I've finished with this testing. SDA, let's do that one. Make that one /home. Okay, that'll do. Let's see what happens now. I suppose I could capture the size, the old size and the new size, couldn't I, and put it in the dialog. That had occurred to me.
Yeah.
Yeah, I might do that. Well, I'm not going to. I might do that at some point in the future. I'm not going to go and do that now. That is definitely outside of scope at the moment. I'm just focusing on hard dependencies now. Okay, let's try this. Aha, it works. Okay, good, because my real-time clock is physically disconnected from the Raspberry Pi 4. Would you like to? Yes, I would love to. What happens when I say that? Does it work? It hasn't errored out, so that's a good start. Let's pause that. Tune to FS SDA. No, hang on. It would be. So this RTC script, all it does at the moment is it disables. It basically changes the flag on the ext file system to disable file system checks, rather to disable the requirement for file system checks when you mount it. Which is, if you haven't got an RTC, your system's going to boot with a date that's way out of sync with
1970 or 2015.
Yeah, and it will complain when you boot, and there will have to be manual intervention. This script at the moment, though, only supports disabling checks for ext-based file systems, so ext 2, 3, and 4. It's never supported any of the other ones. I don't even know actually about whether you need to disable file system checks, or even if they're a thing with other file systems, because I've so rarely used anything like in the last 25 years other than ext that I don't actually know. I've got a note in there from years ago that you don't need to do this on JFS file systems, but for the moment I'm just going to leave it with ext and figure it out if it becomes a problem, because that requires more coding than to then again detect the file system, then again find the right admin tool to go and make those changes. So I'm sticking with ext at the moment. So the actual system won't, if it doesn't detect any ext file systems at all, it won't offer you the option. If it detects one or more, then it does, and it only works on the ext ones. What was I going to do? Oh yeah, so okay, so let's have a look at what's going to be the OS FS tab. And that's going to be this file here. This is the temporary file that becomes the /etc/fs tab file within the OS. And you can see that doesn't quite fit on the screen, does it? Let's try that again. Still, it's quite a long comment there. It's actually quite a bit odd, actually. I wonder if that's. Ooh, okay. I think that script has definitely broken it. And I'm just going to try something. Hold on.
Oh, yeah, I forgot about that. I had to change that. I'm not sure which computer it was, but I had to fix that comment in my FS tab.
Okay.
Yeah.
Right. Okay. So that means, yeah, I know what it's doing. There's a bit of code in there that does it, but I think basically it tries to sort out the alignment of text, because it adds a. Where is it?
Completely forgot about that.
Yeah, it adds a.
Pi4 I had the problem.
Hang on. Okay, so what I'm going to do, let me reboot the machine again, and I'm going to change the code. Yeah, it's this bit of code down here. It basically tries to. Yeah. Oh, okay. And anyway, that only works if your file systems begin with /dev, which this doesn't because it has labels. I'm just going to take this off because this here, this printf %16s blah blah blah, that's just a way of formatting the output that you get from sed here. And it's actually not consistent with Slackware ARM anymore anyway, because I had to change it to line up with disk labels like nicely, so it's not even correct anymore anyway. So I think I'm just going to comment that out and call it good. I don't maybe I'll look at that at some point in the future, but that is really not that important anymore. All right, try once more and it should work. This is how it's done, you know.
That's
Yeah,
what I
most
was
of this,
doing. I was just
code,
running the
huh?
compiler over and over with patches. And I'm like, oh, that one doesn't work. I'll just remove that. And I'll just start over.
Yeah, that's how you do it. I mean, a lot of the code that goes into the installer, I test within the running OS because you can, but sometimes you still got to test it all from within the installer because not everything is the same. Oh yeah, here you go. Look. Oh, that skipped off the screen. But one of the other things that I've done in the Christmas period is if there's an RTC, it's just the DS13 something. I've forgotten now what it is, but let's have a look actually. Where is it? Boot. Oh, sorry, not /boot, / yeah. So if I do load.scr/27, one of the other things that I've done here is, and this I thought was actually pretty useful because what I've done is I've made on the Raspberry Pi, I've directly supported the RTCs that are based on the DS1307 chip, right? So if it detects one of these in the boot sequence after it's loaded the kernel modules, it will initialize it. So my RTC, if it was physically connected on this Raspberry Pi, it would actually be working. So the way I've done that is within this. So I've basically created another layer of abstraction in a way by within this helper script. You can create a function, you can create a function that is then called upon loading of the kernel modules. So at this point in time when this script is executed, the kernel modules aren't actually loaded because all this function originally did, all this helper script originally did, was set a bunch of module variables to support the Raspberry Pi 4. But you can't light up some device if the modules aren't actually loaded at that point in time. So it creates up a post-load function from within the script itself, and then the load kernel modules detects if this function's been created. It detects if this function exists and then executes the function. So it's quite a nice way of being able to contain within one helper script other functions that can be called at later times throughout, that can be called at later events within the kernel module loading process. I thought that was quite good actually. And there's a bit more scope here as well because you can also do. I thought I could also add hooks in for init itself. So just before init pivots into the OS proper, I could add another hook in there as well. I just haven't written it in yet, but I could do. I haven't found a use case for that yet, so I haven't done that. But this one, yeah, I was quite pleased with that. So, because have you played around with device tree overlays much with the native bootloader on the Raspberry Pi?
No, I have not. No.
Okay, me neither. But I started looking into it, and because U-Boot doesn't support, at least presently it doesn't, in the 2021, I think the December 2021 release, it doesn't support device tree overlays, which is a Raspberry Pi thing that they've created. So it means that you need to do things like this with I2C detect and then initialize it kind of manually, if you like. But with device tree overlays, you can configure that. You can configure this RTC that's connected to the GPIO array within the bootloader config by using a device tree overlay. So what I've done is if users want to use the Raspberry Pi native bootloader, you can add in this SLK RPI NBL, which means, what does it mean? Slackware Raspberry Pi native bootloader. NBL means native bootloader. You can add in that as a kernel command line, and then this bit of code here won't be run because it'll be unnecessary because you can configure it within the Raspberry Pi bootloader as well. I haven't tested that yet, but all of the code to support kernel upgrades has been done as well. So you should, whenever you do a kernel upgrade on this machine, it would also upgrade the kernel in the bootware, within the hardware model native bootware partition, which is in /boot/ whatever it is, HWMBW or something like that. So that means that users can I'll document on the installation documents about how you can migrate to that if you want to, because there's no technical reason why you can't do that. So yeah, I added support for it. The only thing I haven't done yet is tested booting using booting the Linux kernel from the Raspberry Pi native bootloader, and I haven't tested the DTO stuff either, but I'll get around to it. I'm pretty certain it'll work. I can't really see a reason why it wouldn't, apart from some sort of a misalignment between the DTBs that I'm shipping versus the ones that are in the Raspberry Pi bootloader GitHub repo. I don't know if there's a problem. If there's a
actually, you can just use them.
Yeah, I'd imagine that you could as well. So I'm not concerned about that. So yeah, I'll test that later. So what I'll do is I'll just let's test this again. Oh yeah.
Yeah, I've been holding off on telling you about more things that I've done until after 15's out. For like the Raspberry Pi 3 and the Orange Pi and stuff. So.
Yeah, you'll have to talk to me about the Raspberry Pi 3 in a minute.
Okay.
Oh, let's just do this. I think this should work now. Oh yeah, look, there we go. The NVMe is back at SDA2 again. I'm really glad I did the labeling now. Oh yeah, I'm really glad. Oh, the other thing I'm going to do, just to do something different, is for the Raspberry Pi 4, I thought I was in between. Hold on a minute.
Just whatever you do, don't plug in the GPIO headers with 5-volt and 3-volt at the same time. And then you won't find Raspberry Pi.
Don't do. I couldn't hear that. What was that?
Oh, don't plug in your GPIO headers to your serial adapter when you have the 5-volt and the 3-volt connected. It just fries everything.
Oh, okay. I've not done that.
Yeah, it's not fun. It was an accident.
Right. Yes. Let's try this. Okay. Good. So. Oh yeah. So let's have a look. So log setup. Oh. Okay. Oh, there we go. It's fixed. That bug is now fixed. Done. Can now rebuild the installer image. Was it again? I said cat E star RL star Z. Sync reboot. So now I'm deploying the Raspberry Pi 4 Slackware installer image onto the micro SD card in the Raspberry Pi, and it's going to reboot. So it'll have a completely clean installer image that hasn't been resized and all that kind of stuff. Then I'll put the new RTC script back again and retest it. Right. What I'm going to do is connect the Raspberry Pi RTC up. So this is the Raspberry Pi 4 that we've just been working on. Here's the NVMe. Here's the NVMe to USB adapter. So I've got my NVMe inside here, inside this enclosure. I'll document which this enclosure is on the installation documents. So there's that. There's the NVMe. And there is the SSD that's been detected as well, which is connected to the USB to SATA adapter. And here are the DuPont wires. I don't know if you can really see those properly because the light's not great under here.
Yeah.
Yeah, it's a bit dark, isn't it? But anyway, maybe put them out a little bit. Yeah, so those are. Oh, yeah, so those are the DuPont wires that are connected to the RTC, or were. And there's the Adafruit RTC with a battery in it now. So I've got a 3-volt battery in it. Somebody had said to me that you shouldn't connect the 5 volts unless you've got a rechargeable battery. However, this Adafruit RTC is designed, I don't know if you can see that down the back, but it's designed to fit directly onto the GPIO pins, one of which is actually a 5-volt pin, which is this red one here, which I'm powering the fan from. So it's actually designed to take to sit on the 5-volt pin and the 3-volt pin. I don't know, I wasn't able to ascertain by sight whether the 5-volt pin's actually wired to anything though on this peripheral. But I don't know. But anyway, that means that you can wire a 5-volt pin to it. I just don't know. It's not going to break it because it's designed to take it. So, you know, I don't know if it's, but I haven't anyway because there's no need because I've got a 3-volt. I don't have a rechargeable battery in it, and it runs off 3 volts anyway. So, yeah. So let me just flick back to the.
That's quite the heatsink you had there.
Well, yeah, this is the one that Phil recommended, and I think it's good. It's, you know, can you hear it? Actually, you probably can't.
No,
You'd only be able to hear my MacBook, which is making a bit of noise. But I can't hear this fan at all, and it's running on 5 volts. So, I mean, it works fine to me.
Yeah, I had to lower mine to 3 volts, the fans, because it was too loud.
Maybe it's just the quality of the fan.
I think so.
Like the Rock Pro 64 fans are loud. I had to lower mine to a 3 volt for the Rock Pro 64 because it was so noisy.
Yeah.
But this one is not. So, yeah, it's good. But yeah, the only problem is with this, as you can see, it precludes the use of connecting little devices like this to the pins. So one of the guys, I think his name was Tom, sent me an email with a picture of his Raspberry Pi, saying that he'd show me how he'd done it. And what he'd done, he'd built a little, which is what I'm also going to do actually. I started doing it on this side. He'd built a riser with these little, what do you call these sort of spacers? I don't know what the proper name for them is, but these little copper. Well, they're not copper actually; they're brass. These little brass spacers here, and what I'm going to do is screw that like that, and then I can keep it secure because at the moment it's just dangling on the desk. So I'm going to screw that in, and then that's secure like that. He got his like way up here, but you can put it like that. So that's what I'm going to do there, and I'll document that as well. But yeah, so you can see that that's disconnected. It's a boot, and it's not booting. Hang on. I'm just going to power off the machine.
Yeah, sometimes my Pi4 it comes with the wrong disk. It tries to load the wrong one in U-boot, and then it doesn't boot.
Oh right, okay. This is interesting. Look, since I'll reshare the screen actually. Can you see the U-boot booting?
Yeah.
Since I've connected the NVMe enclosure, you can see here that U-boot's failing to boot. And that's the only thing that I've changed. So what I'm going to do is if I power that down, it was all right before though. You saw it booting, so that's interesting.
Yeah. The bug.
Let's try that. Just see if it works. Huh, yeah, okay, interesting. All right. See how that behaves when I've got different types of storage installed. I'll have a look at that. Okay, yeah, so it boots the installer. So what I'm going to do now is just look at my photos of how this was wired up. I must say, you know, Brent, part of the physical work of doing this, like, one of the things I did as well over Christmas is, so I was testing the installer with all the labeling support, and I went to reboot one of my Rock Pro 64 primary builders, and well, no, I didn't actually. I went to rebuild the image on the primary builder, and it was unavailable. So I looked at the serial console on it, and it was just waiting for the root file system to light up with, you know, dot, dot, dot. And I realized, oh, I forgot to add in labeling support for the for the await root file system function within the kernel module loader. So I went and added in labeling support into that. But then I realized what had happened in the first place, because I was thinking I didn't reboot the machine. I'm pretty certain I didn't by accident. And then I found out what had happened was the ATX power supply that I got donated from somebody in the local community had failed, and so it's pretty old. You know, it'd been around for a while, but it had failed, and it'd taken the hard drive and the fan down with it. But the Rock Pro 64 was powered off of a separate, you know, the power supply you get with it. And it was just the machine was booting, trying to find the storage, and the storage his lights were out. So
Doesn't have enough power.
It just died. Just the PSU had just died. So I just got another one out of the stash I'd been given and just chopped it up again. And this time I've got the entire Rock Pro 64 powered purely from an ATX power supply. So I found some old power supplies in the attic with the same connector as the Rock Pro 64 and just spliced them into a 12-volt line on the ATX PSU. So the whole thing is now powered. So I've got less cables on the build rack, which is nice. Right, so let me just double check this.
Trying to get rid of wires all the time and having to add more. And
yeah, I can't stand having wires everywhere. Like it upsets my mental zen, you know. It's true. I'm okay to a certain degree. It's quite funny, actually. I had a colleague years ago when we went to a customer's site, and it was like one of those kind of dynamic companies that, you know, there's lots of organic growth and all things going on, you know, and people's desks were often an absolute tip, and this guy would get really nervous. And I thought it was hilarious because I was thinking, God, I'm glad I don't have to work here. You know, I felt great about the fact that I didn't have to work there. I was like, thank goodness my office isn't like this. This guy was like really stressed out about it, and I was loving it. Right. Okay, I think that's wired up correctly. So if we, yeah, let me just tell you what, I'm going to go with just the NVMe enclosure this time, because I don't actually need two primary storage devices. Yeah, so let's see. So hopefully, oh, hang on. So that's,
yeah, I just moved everything into a cluster case, but I'm using it like a miniature rack mount case instead.
oh, I saw your photo. Yeah, I saw your photo. You need to show me that. What's going on with the other one? Because you've got one that has like, yeah, has like a multiple, has sort of slots for multiple boards or something, I thought.
Yeah, it just pops in there and there's a fan for each slot.
Okay. Yeah. So I've got the Adafruit RTC wired up, back how it was. And I've just got the NVMe enclosure connected to the USB bus now. I've disconnected the SSD one. This is good, Brent, because I was planning on doing this RTC testing. I wasn't planning on doing it on the video, but it can be another Slackathon, I guess. Right. Okay. Yeah, there we go. So there's SDA. We just got the NVMe from the old Pinebook Pro. But so let's see. So yeah. So let's have a look at the. So I'm just going to copy the latest version of the script back again. So this time, it should not ask about the RTC. And I've only got my one swap partition now. And there's a single root file system. Oh, that was fast. Okay, yeah. Oh. Ah, no, this is what I mean by, because I didn't umount/boot when I last deployed the image to the SD card. Do you see all of the errors that came up?
Yeah.
So resizing was successful. It's going to detect the Raspberry Pi hardware model bootware. Okay. Hopefully we don't get presented with an RTC. Yeah, we don't. Perfect. So Brent, the other thing I was going to change. There we go. I think I should have that as my epitaph. Do you know how many times I've typed in the full directory path to install this? For it makes me read every time I do it. Like every now and then, I keep thinking back to these conversations that I had with Eric Hammerly years ago about rebuilding like redesigning the Slackware installer to make it automatable. And yeah, it's just such a piece of work. It's not even, it's just the amount of time I've spent working on the installer recently to go and re-implement the installer is it's like years of work to get that tested. It's so much work. So I'll keep typing it in for the time being. Or maybe, yeah, keep doing that. One of the other things I was thinking about doing was with the Rock Pro 64, I've got it where you're setting up this Python simple web server on the what I'm calling the Linux host computer, the machine you DD'd the image to and downloaded the assets and stuff like that. And you run that Python web server on there. But I was thinking for the Raspberry Pi, I wonder whether another option, or maybe not necessarily a better option, but another option that's worth documenting is simply to, when you download the assets, put them on a USB stick, make the file system on it and put the assets on there and then install off of the USB stick. I think I might document that for the Raspberry Pi and not, and reference the Rock Pro 64 if you want to do a network installation. Yeah, so I was wondering whether it might be a better option to document that for the Raspberry Pi. What are your thoughts on that? I'm not going to document both of them because I don't want to complicate these.
Setting up NFS and like TFTP or however people decide to install it, most people don't know how to do that, and they just want to be able to install and get going.
Yeah.
So if you set like a pre-mounted directory or a partition, it's easier to reinstall too if you have a spare partition. So I don't know. But what I do is I put like a swap and a root on one disk, and then I make like a data partition, and I keep my repo there.
Oh, I see. Yeah, if you're doing what you're doing, but if you're a new user that has a Linux box and you want to try Slackware on it, possibly one of the easiest things is to just mount a USB stick. Well, create an X file system on the USB stick, copy all of the Slackware AArch64 tree onto it, and then install off of that. So it's just because I was just thinking maybe running a web server might be a step beyond what some people can do or are comfortable doing, although it's easy enough because you just paste in the commands. But
or they leave it running as root and forget about it.
Well, you wouldn't be running it as rooted with my documentation. You run it as your own. But yeah, I'll document. I think that's what I'm going to do. I'm going to document that because then it's an alternative option, and it means that you don't need to just to have that step of networking there. In case there are any issues with accessing on the local network or anything like that, maybe. So so I think I'll do that because it kind of simplifies it in a way.
Yeah, and some people don't always have a second computer to use as the host. So
well, you've got to use some computer.
Yeah, like they download it somewhere else to keep it on their thumb drive, and then go home and do it, type of thing.
That's true. Yeah, well, yeah, that's true. That's true. Yeah, that is a good point. So yeah, okay, good. Yeah, I'll do that then. Yeah,
because not everybody has like the internet or whatever,
Yeah, exactly. Okay, good. That's made up my mind in. Yeah, so I'll document that for the Raspberry Pi, but the other ones I'll leave. I like to have different options available that are nicely documented. Yeah, there's been loads and loads of work over Christmas on this with all the labeling stuff and sorting this out. And there's probably a few other things that I need to add in, but other than that, I'm pretty happy with what's going on. Yeah, I just need to test sound on the Raspberry Pi 4. Haven't got around to that yet.
Well, it definitely works on the Rock Pro and the Pinebook, but I can try out the 4 later today.
Okay.
Gotta replug things in.
Cool. Yep. Then I've got to test out the device tree overlays. I want to make sure those work because I'm going to document how to migrate to that if people want to use that. Because if people quite like using the device tree overlays, which to be fair, looking online, I mean, I've figured out how to get it working without using device tree overlays because that's very well documented as well. But the device tree overlays are also very well documented. So in some respects, there's no reason why not to use that bootloader either. But So I think it's brilliant actually, because you can boot with U-boot, so all of the existing process or the workflow works. But then to migrate, it's really easy. It's like it's literally you paste in one command into the shell as root, and it will convert it to using. Well, actually, that's not true. It'll set the kernel command line up properly, but you still have to go and change the config.txt file to make it boot. So that it specifies the Linux kernel directly, and rather than U-boot.
Yeah.
But that's all documented in the config file anyway. So you can just literally go and comment it. So
one thing that I want to look into that I haven't really paid attention to yet is, you know how like there's other configuration settings in the config.txt. We have a very minimal configuration. So if you look at a default configuration for a Raspberry Pi, it has lots of extra settings.
Yes.
Besides just like, yeah. So I don't know. Have you played with that at all?
No. I know what you're talking about though. Let's have a look.
So like if someone wants to change the amount of GPU memory or whatever.
Yeah, but okay. So this is the default config. So this is the default config, and that's pretty much it, right? You've got these 2 lines and this line here, so 3 lines, and then that boots U-boot. But I don't believe if you set anything else, I've not tested it, but I can't imagine that setting much else here is going to make it into U-boot, because these config here's, these config settings here are for this bootloader, whereas really so you'd have to configure that stuff in U-boot. I have included this here. So this that you see here that's all commented out. This is how you can go about switching to use the Raspberry Pi native bootloader. And I've got some information here about device tree overlay. So like here's an example of how you could set up the DS1307. So instead of using what I've got in the kernel loader helper script, you can set it here instead. So I'm open to having more examples included in here, commented out if they're useful.
Yeah, that's something that's been on my to-do list, but I haven't really looked at it yet.
Okay. So. Well, yeah, those things aren't too important really at the moment. I just want to test the DTO for this one because that's all I've got. I've just got this RTC here. But on the internet, on the web, there are plenty of examples of how to set up device tree overlays for various different peripherals. So hopefully that works when I go about testing it. Because I've written all the documentation assuming that it does. I've been optimistic there, but I don't see why it wouldn't work. If it doesn't, I'll fix it. Yeah, so that's kind of where we are with that. Might move to Linux 5.16 pretty soon, I guess. I'm not sure about that yet. But that would also be good. Hopefully some of these patches for the Rock Pro 64 and Pinebook Pro can be dispensed with. I have no idea. I haven't checked whether they've been upstreamed or not. But I was thinking, the reason I say that is because I was thinking about, we were talking before Christmas about it, I think. One of the things is that in order, if you've got another hardware model, let's say the Orange Pi R1 that you've been looking at, if that required a whole bunch of patches for it, that could be a bit of an issue, because at the moment, because I started with the Rock Pro 64, because the Pine 64 company gratefully donated me some hardware for the project. So the origins of the project are based on the RK3399 SoC. What that means is that, that's like the core build machines that I have. Like Slackware is it's not an operating system for a particular hardware model. It's for many hardware models, but at the same time, I still need to make sure that I maintain the 3 that I'm supporting, presently. So the Raspberry Pi 4, the Rock Pro 64, and the Pinebook Pro. The thing is that if, say, the Orange Pi R1 needs a bunch of kernel patches, that may be an issue, because if they don't keep in sync with the latest kernel release, then I can't support that thing.
Yeah.
You see what I mean? Like if they get stuck at Linux.
I'm kind of holding off because I'm waiting for some stuff to get mainlined.
Yeah. Yeah, this is one of the things I was looking at. I was always busy working on the Raspberry Pi support and assembling all the kernel modules. It has a PoE driver. That module is not in the vanilla upstream kernel at kernel.org, whereas it is in the Raspberry Pi kernel branch. So even if there's a patch for it, I'm not going to take it. Even if there's a patch to make it work in the kernel.org, I'm not going to take it because I don't want to get into a position where as soon as you start straddling a single generic kernel over different, including patches from different branches of different forks of the kernel, you're going to get yourself into a very unstable state pretty quickly. You're not going to be able to move forwards. So really, I need to I don't mind tying myself to a collection of patches for one hardware model platform like the Rock Pro 64, which is actively maintained. But and some of those patches are sent upstream. But yeah, like you were saying, you really need to wait to see, to get them into the mainline Linux kernel, really. So that's one of the things that happens here. And people have said to me before, well, you can just use you can use a kernel from, say, the Raspberry Pi GitHub or wherever it is, right? Download their kernel tree with their config. All right, that's great, you can, but guess what? As I'm developing Slackware, I'm expecting the kernel to be the one that I'm using. And if I want some support for something, like for example with the initialization of the RTC, that's contingent upon my kernel config. And right, so Slackware is being designed and developed with the kernel config, and if I need to change it, I change it, and then it's going to be, it's the actual operating system is in line with the kernel. So as soon as you start diverging by using a different kernel, you could break the OS. I mean, to be fair, that's a bit dramatic. You're not going to necessarily just break it, but there are going to be certain features that may not work. They're intended to using the official kernel.
Boards out there that just have the RK3399 chipset. So, I mean, it shouldn't be as difficult to add new boards if you stick to like what's supported.
So talk to me about the Raspberry Pi 3. What's been going on with that? You started looking at that?
Yeah, I mean, I just dropped in the entire firmware that comes from the GitHub of Raspberry Pi, and it just started booting. So,
okay.
Yeah, it's like some of the Allwinner code that makes up the device tree source builds off of older ones. So like the Raspberry Pi DTVs, they kind of depend on some of the older ones for functionality. And so I just started adding in one by one, and as I did that, I noticed things are starting to work more and more. So I don't know. I'm kind of torn about what needs to be added and what doesn't need to be added.
Okay.
But the kernel that you have right now is working with it, so I didn't have to change anything.
But the module loader is not complete though, right?
Yeah, I added in, I forgot what I added in. I have to go look at the Raspberry Pi 3, but I took some of the modules that were loading from the Raspberry Pi 4 too. I added in like maybe, I think it's 4 or 5, and that's it.
You've taken the Raspberry Pi 4 version and just changed a few of the module names, then I can certainly include it. I mean, because if it boots, then, and it kind of mostly works, I'm not going to certainly aim to.
Well, the other thing is I have the Raspberry Pi 3B, and my 3B Plus, which is what most people probably have by now, is broken, so I have no way to test that.
Oh, okay.
Yeah.
Okay. Well, that's fine.
The USB bus somehow.
Okay. Well, yeah, just give me what you've got, and I can just include it, and if it works for some people, and just, I'm not going to make any instructions for anything. Just leave it as kind of just document where it is. It kind of boots on the Raspberry Pi 3, and if someone wants to get that working on their Raspberry Pi 3, they're welcome to help, and they'll be able to read the direct integration instructions and figure it out. It should be pretty straightforward.
Yeah, I haven't added to the hardware model scripts yet. I've just used my original script that I used for the Raspberry Pi 4, and so it shouldn't be that difficult to add it in.
Yeah. Oh, and then yes, it'll need an SD card build script entry as well, wouldn't it?
I think so, yeah.
And probably for U-boot as well, actually.
I think it actually boots with the same def config, the Raspberry Pi underscore ARM64 for U-boot, it still uses that. So that's why I was like, maybe we should bundle it all into one thing. Because it uses the same binary for U-boot. So I don't know.
Let's see. There is, yeah, I've thought about this before. Well, I mean, yeah, if it's exactly the same, then, which you're kind of right, it is actually. I thought there was going to be a difference. I'm just trying to think through what that could be, but you're right. The U-boot config is static. It should be identical because it's just got a name of U-boot in it. And the hardware, in terms of the kernel upgrade process, that's going to, there's a new helper script that I've added into the kernel. So within the kernel package post-installation script, this is where it calls the operating system initial RAM disk manager. And then it detects whether there are any helper scripts inside this /boot/platform ARch64 helper directory, which there will be on here because it'll be here, helper. And then you've got package kernel. And what this does, oh, I meant to cat that. And what that does is it detects whether you're on any Raspberry Pi, because I assume they would follow this standard template. Sounds like they will. Yeah. And then it will copy then the initRD in the kernel and the DTBs onto the mount point for the native bootloader stuff. So that already supports it. Mm-hmm. So yeah, we could probably get away with just having one of them.
A few of the DTBs and then some modules added to one of those scripts.
Yeah. Well, yeah, the DT, yeah, exactly. I think the Raspberry Pi 3 will need, it can have a separate kernel module loader script for sure, because that makes it, I want to do that because otherwise it's, because I don't think all of the same modules work or are required on the Raspberry Pi 3 and 4. They've got different chipsets, so some of the names must be different.
Yeah.
But but in terms of this is just copying kind of indiscriminately, really. It's just copying everything from Broadcom, which includes the Raspberry Pi 3 stuff. So if I look here, for example, we should see, even on Bladsread, which is a Rock Pro 64, yeah, you can see there is the Raspberry Pi 3 DTB. So it's all set up to go.
Yep.
Yeah, okay.
And all I did was add a load kernel modules.post script to boot local, and there's 5 modules. That's it.
Oh, okay. Well, just give me the module. Oh, just give me those module names then.
Yeah.
And then whatever it is that you've. Oh no, you're saying it boots, saying it's unsupported. So that means that pretty much.
Okay, it's unsupported because I haven't edited the platform script yet. That's all.
Exactly, but you're saying that the base set of modules in here, which is in this script here, which applies to all platforms. So you're saying that it's booted with this plus a few modules that you've got in the post-installation boot script.
Yes.
Perfect.
Yeah.
Okay, yeah, cool. Send me that over, and I'll include them in. I'll make a Raspberry Pi 3 version of the plugin of the helper script with those modules in it. Yeah.
In IRC. Just a bunch of mod probe lines, and that's it. I'm pretty sure that can just be added in to the same script.
Yeah, but I don't want to match because the naming convention is based on SOC name, not hardware model. I need to separate the helper script files because the naming convention is based on SOC name, not hardware model name. Otherwise I'd have the BCM2711 with a hardware model match for the Raspberry Pi 3, but that doesn't use that chip. That doesn't use that SOC. But so yeah, just send me the modules and I'll do that. And then with the SD card image, yeah, once I've added that in, if the Raspberry Pi 4 SD card image works on the Raspberry Pi 3, I will
I just started calling mine Raspberry Pi ARM64 because it works on both of them.
Yeah, I'll do the same then because I haven't. Yeah, I'll rename that then in that case. Cool. That's good to know. Yeah.
Just simpler. To do
Yeah.
that.
Well, yes, exactly. If that works, so that's good to know. So I'll do that too. There's a particular name, isn't there? It's in is it, what's it called? Yeah, once you send that to me, I'll have a look at it. I'll bundle it in and build it, rename it.
Yeah.
Because then, yeah, that makes sense.
Just like RPI underscore ARM64.
Yeah, but then it breaks the naming convention of the sock. Oh, that's just for you, Boot, though.
Yeah.
Oh, of course, yeah, because this is not okay.
Yeah, I should probably just look at that today and get it done. It's almost done. But
what I'm thinking is just if I commit to having one generic. The thing is, it breaks the naming convention.
I know.
Because,
I mean, if you really wanted to split them up, you could just add the firmware for the Raspberry Pi 3 and then the loader script, and then just make a separate image.
Yeah, I can make a separate image. It's not a big deal.
Yeah. The trick is to figure out which firmware files it needs and doesn't need, because I copied everything in for my installation.
Oh, I've already figured that out. That's already done. So that all of that stuff, I assumed that the Raspberry Pi 3 would be supported at some point. So I've taken care of that. With the Raspberry Pi 2, no, but no one's going to be interested in that, I think. In fact, I don't think the Raspberry Pi 2 is not 64-bit anyway, is it?
No, it's a 3 and the 4, and that's it.
Okay, yeah. So this would already work for that. Yeah, I'll think about how to do that, and then
it needs a couple of the BCM 2710 PCBs for the 3D. So, because we just have 2711. And
do you know what I'm going to do? Actually, I'm going to take the really easy route because the easy route is better. So
yes.
what I'm going to do is I'm going to,
instead of having them build an image and then see if it boots, and then it doesn't boot, oh crap, gotta start over.
no, I'm just going to make a symlink from one sock to the other.
Oh, God.
Because the thing is, if for some reason they have to diverge in the future, I don't need to redo any documentation or anything.
Yeah.
And so, and that way I can just, I can make it build a separate image, and it doesn't matter. It's like a few hundred megs. It's just, it's of no significance whatsoever, no consequence whatsoever. So, and like you say, they're kind of, I can change the actual names in here, so it doesn't just say Raspberry Pi 4. It has 3 and 4. But in terms of, I'll just make a separate image because it is a different sock. So if we do have to do anything different in the future, I don't have to go and separate them again. I think that's the best solution. So that's what I'll do. I'll take care of that. Yeah. Makes sense to me.
That's kind of where I left off. I was like, oh, what am I going to do with this? So I was kind of thinking about it.
I'll do that part now. What is it? This one, isn't it? 2837.
Yeah.
Perfect. Part of the work done. Right, great. There we go. Yeah, and then I'll just change the.
That's actually what other distros are doing too. So.
Oh, is it? Well,
yeah, other boards besides the Raspberry Pi.
It makes sense to me.
Yeah.
Yeah, I'll sort that out later. Cool. All right.
I just spend so much time looking things up, and it's like there's a lot of gray area that people haven't agreed upon yet. So.
All right. Yeah, so I'll get this stuff done. I will rebuild. Actually, I need to rebuild the installer image again, so it's got the latest RTC code in there. So I have a few people who emailed me who want to test on the Pinebook Pro. So hope to kind of be able to get that set up so they can access the private repo probably by the end of January, maybe a bit earlier, I don't know. Depends how things go.
I'm sure you're also busy with just regular Slackware stuff that's unrelated to ARM. So, with the release.
Yeah. Well, there's been quite a bit of work just on the labeling and testing that for 32-bit as well, but that's all done now, thankfully. So yeah, there's loads of other stuff that needs to be done, but I want to finish off first I want to finish off the Raspberry Pi 4 installation documentation and get the installation video done for that as well, because I think that's I think I was looking at the documentation and I like the way it's straightforward, but there's still quite a bit of it, and I think it's so easy with the video to see how easy it actually is. Sometimes people can be put off by looking at voluminous documents, even if they're only 3 or 4 pages long. But certainly with the video, it's so easy. You can see how easy it is to do. So I really want to get that done first, really. But yeah, I think we're all pretty much good to go on that front. Okay, so we're back on the Raspberry Pi 4 now. The installer is finished. Do you want to remove it? Yes, I do, because it all looks good. Yeah, I'd love to configure my network. No. Yeah. No.
How many time zones?
Oh, by the way, on the Pinebook Pro, do you still have to power it down after the install to get it to boot properly, like I used to have to do?
Only if there's another storage device plugged in.
Okay.
U-boot tries to boot from whatever it finds first, and sometimes that's what happens.
Right.
Not every time, but sometimes. So.
Okay. Good to know. Let's see how it handles.
For example, if you just did the install and you rebooted, but you still had your thumb drive plugged in or something,
Okay. Right. Okay. Yeah, I'll have a note in the installation documents to say, you only insert the installation media, the USB stick with the data, with the Slackware packages on it, when the dialog screen is presented to you, and then you can disconnect it before you reboot. Yeah. I think that's the safest option. Well, so this is the Raspberry Pi. As you can see, the RTC has now been initialized, and it's booting off of the NVMe in that enclosure that you saw earlier.
I might have to get one of those.
Yeah. I was a bit concerned because when I bought it, I just went on Amazon and just went, oh, that looks like a nice one. Had to look at the specs, made sure it matched the NVMe from the Pinebook Pro. It did. So I bought it, and then I suddenly realized, oh, I wonder if it works in Linux. So I didn't even check, because usually everything works in Linux these days with the latest kernels. So then I went back, and it does say it's supported by Android and Linux, although that doesn't really mean very much, because it could be supported by some random vendor Linux branch somewhere.
Kernel 5.9.
Yeah, exactly. But this one, it works perfect. So I'm happy with that. Yeah, and I get to use my NVMe, which, this is a funny thing, right? This NVMe started to fail on the Pinebook Pro, so I bought a new one. I bought a 250 gig version, and as you can see, it works fine in the Raspberry Pi. So I don't know what's happened to my Pinebook Pro, but it boots. I get it to. Previously, it wouldn't power on, and now it does power on. But as soon as it boots the kernel from U-boot, it just powers off. And I reverted to Manjaro because that's still on my eMMC. And
Did you try with the latest kernel with that patch removed? Because that's what mine was doing.
Oh, well, I tried it with Manjaro and it wouldn't boot either, even with the old Manjaro on the eMMC. So it's, because this is also one of the reasons why I keep the original Linux distribution in case I go way off the rails. Yeah. At least I can revert back to the factory, known good state, and it didn't work either. So it's a hardware problem. It'd be nice if Pine64 gave me another one, although I'd probably, they've already been kind enough to give me one, and they've got I don't think they've got a huge availability of stock of that, from what I can tell. Speaking of which, I went to buy a new Raspberry Pi today, a Raspberry Pi 4, so that I've got one that I can keep as a known good running machine, and have the other one to run experimental code on. And I found that the piehut.com I was buying it from is out of stock of Raspberry Pis, of all of the versions of the Raspberry Pi 4.
Yes. And if you look on Amazon, they're like $150.
Wow.
Yeah, that's my problem right now.
Okay.
I have 2 Raspberry Pis left and 3 slots in my case, so there's a problem.
Yeah, so it's, you know, I don't know if that's a mixture of like issues with shipping and the pandemic, or it's just, you know, there's been a huge interest in them. But
Yeah.
you know, I'm really looking at this and I'm thinking, this is so easy to run Slackware on this machine, or on any of them actually, on any of these boards now, with all the development that's gone on.
Yeah.
So yeah, I'm really pleased with this. I'm hoping now that I've got, I think, all of the core stuff for these sorted out, that yeah, we'll be able to release it reasonably soon.
Exciting.
It's good to talk to you. Is there anything else going on that you need answering, or any questions or anything?
No, mostly just trying to figure out how to get this launch part of it, but
Oh, I
I'm
saw your
getting
message.
Yeah.
No, I saw your message. I've no idea what that's wrong with that.
I've been getting so pissed off at this thing.
Yeah, we can
Throw it
get
out.
like that. It really can get like that. All right, man. Take care. I'll see you on the next
All right.
one.